Hello everyone, welcome to Edupedia World. Today we are going to discuss acids, bases and salts. The topic is covered under the following heads. First we will discuss physical properties of acids. Acids are sour in taste. They are highly corrosive. Acids such as hydrochloric acid, sulfuric acid and nitric acid are highly corrosive. Acids can be present in liquid or in solid state. And aqueous solution of acids conduct electricity. So these are the physical properties of acids. Now let us discuss chemical properties of acids. Action on litmus. Acids turn blue litmus red. Second, reaction with carbonates and hydrogen carbonates. Acids on reaction with metal carbonates and metal hydrogen carbonates liberate carbon dioxide. Now, reaction with bases. Acids form salt and water on reaction with bases. The process of formation of salt and water when an acids react with a base is called neutralization. We can see in chemical reaction that this process is called neutralization process. What happens in neutralization? Acids reacts with base. To form a corresponding salt. So this process is called neutralization. Suppose sodium hydroxide reacts with hydrochloric acid. It will form NaCl and water, sodium chloride. This is the salt. Now let's take another chemical reaction in which copper oxide reacts with sulfuric acid and it will form copper sulfate and water. So acids on reacting with base forms salt and this process is called neutralization process. Now reaction with salts. When an acid is heated with a salt, the less volatile acid displaces the more volatile acid. What is volatility? It means the boiling point. Volatile. It means boiling point. We know the boiling point of HCl is minus 85 degrees Celsius. HNO3, that is nitric acid, 83 degrees Celsius, and sulfuric acid boiling point is 338 degrees Celsius. So when an acid is heated with a salt, sodium chloride is heated with sulfuric acid, it will form Na2SO4 and hydrochloric acid. So when a salt is, that is NaCl, is heated with a salt, the less volatile acid, which is less volatile here, sulfuric acid boiling point is 338 degrees Celsius. So it will displace the more volatile acid and so Na2SO4 is formed. Let's take another example in which twice NaNO3 reacts with sulfuric acid and it will form Na2SO4 and twice HNO3. So the less volatile acid displaces the more volatile acid. Now reaction with metals. Acids react with metals which are placed above hydrogen in the activity series to liberate hydrogen, and corresponding salts are formed. Let's take zinc reacts with hydrochloric acid and it will form zinc chloride and hydrogen. So acids react with metals which are placed above hydrogen in the activity series and will liberate hydrogen, and corresponding salt is formed. So ZnCl2 is formed and hydrogen is liberated. Now magnesium, it reacts with HCl, MgCl2 and hydrogen is formed. So the corresponding salt, that is magnesium chloride, is formed and hydrogen gas is liberated. Now take another example. Reaction with sulfides and hydrogen sulfides. Acids react with metal sulfides and metal hydrogen sulfides to liberate sulfur dioxide. So let's take some examples. Na2SO3, when it reacts with sulfuric acid, it will form Na2SO4, H2O, and sulfur dioxide is liberated. They react with metal sulfides and metal hydrogen sulfides and liberate sulfur dioxide gas. Here sulfur dioxide gas is liberated. Now twice NaHSO3, when it reacts with sulfuric acid, Na2SO4 plus twice H2O. So here also sulfur dioxide gas is liberated. Reaction with sulfides. Acids react with metal sulfides to liberate hydrogen sulfide. Let's take some examples. Zinc sulfide, when it reacts with hydrochloric acid, it will form zinc chloride and hydrogen sulfide gas is liberated. Let's take another example. Iron sulfide, when it reacts with sulfuric acid, iron sulfate, FeSO4, and hydrogen sulfide gas is liberated. So hydrogen sulfide gas is liberated when acids react with metal sulfides. Now we will discuss classification of acids. Acids can be classified on the following basis: on the basis of sources, second on the basis of molecular composition, third on the basis of strength, fourth on the basis of concentration in solution, and fifth is on the basis of their basicity. First we will discuss classification on the basis of sources. So on the basis of sources, acids can be classified into organic acids and inorganic acids. First we will discuss organic acids. Organic acids are acids which are obtained from natural organic matter such as plants and animals. All organic acids are weak acids and they do not ionize completely in aqueous solution. Their aqueous solution contain both ions as well as molecules. And the examples of organic acids are acetic acid and oxalic acids. Second is inorganic acids. Acids which are obtained from minerals are called inorganic acids. They are strong acids and they dissociate completely in aqueous solution. Their solution contain only ions. Examples of inorganic acids are hydrochloric acid, sulfuric acid, nitric acid and phosphoric acid. Now, our second classification is classification on the basis of molecular composition. They can be classified into binary acids and oxoacids. What is binary acids? Acids which contain hydrogen and one other element are called binary acids. The examples are hydrochloric acid, that is HCl, hydrofluoride, that is HF, and HI, that is hydrogen iodide. Now, oxoacids. Acids which contain hydrogen, oxygen and other element are called oxoacids. Examples of oxoacids are H2SO4, HNO3, H3PO4, CH3COH and oxalic acid, that is H2C2O4. Now, classification on the basis of strength. On the basis of strength, they can be classified into strong acids and weak acids. First, strong acids. Acids which dissociate to a large extent in a solution are called strong acids. Nearly all their acid molecules break up to form hydrogen ions. Strong acids produce a high concentration of hydrogen ions or hydronium ions in solution. A solution of H2SO4 in water is a good conductor of electricity because it dissociates completely, almost 100% in the solution. Let us understand this point with the help of an example. When H2SO4 reacts with water, it will form twice H3O positive and SO4 2 negative. Now, take the example of nitric acid HNO3. When it reacts with water, it will dissociate H3O positive and NO3 negative. So, it dissociates completely in the solution. Now, weak acids. Acids which undergo ionization to a small extent only are called weak acids, and only some of their acid molecules break up to form hydrogen ions. And examples of weak acids are all organic acids are weak acid, HF acid, hydrocyanic acids, that is HCN, H3PO4, nitrous acid, that is HNO2, carbonic acid, that is H2CO3, ethanoic or acetic acid, that is CH3COH, methanoic acid or formic acid, that is HCOOH, and citric acid and oxalic acid, that is H2C2O4. Now, classification on the basis of concentration in solution. They can be classified into concentrated acids and dilute acids. Concentrated acid. It is almost pure acids with very little water in it. So it is called concentrated acids. And dilute acid is more water and less acid. A dilute acid has a concentration of less than 2 moles per liter. Classification on the basis of basicity. Basicity of an acid is the number of hydrogen ions that can be produced by the ionization of one molecule of the acids in its aqueous solution. And on the basis of basicity, acids can be classified into monobasic acids, dibasic acids and tribasic acids. First, we will discuss about monobasic acids. An acid which produces one hydrogen or hydronium ion by the ionization of one molecule of the acid is called monobasic acid or monoprotic acid. For example, HCl, HBr, HI, HNO3 and CH3COOH are monobasic acids. Let's take for an example HCl, when it reacts with H2O, it will produce H3O positive and Cl negative. So it is producing one hydronium ion, therefore it is called monobasic acid. Now, dibasic acids. An acid which produces two hydrogen or hydronium ions by the ionization of one molecule of the acid is called a dibasic or diprotic acid. For example, H2CO3, H2SO3, H2SO4 and H2C2O4 are dibasic acids. They ionize in two steps. Dibasic acid, H2CO3, when it reacts with water, it will form H3O positive and HCO3 negative. And HCO3 negative, when reacts with water, it will form H3O positive and CO3 negative. So they ionize in two steps. Let's take another example. H2SO4, when reacts with water, it will form H3O positive and HSO4 negative. HSO4 negative, when reacts with water, it will form H3O positive and SO4 negative. And dibasic acids form two types of salts, that is acid salt and basic and normal salt. First we will discuss acid salt. NaOH reacts with H2SO4, it will form NaHSO4 and water. This is called sodium hydrogen sulfate. Or we can also call it acid salt. They also form normal salts. Twice NaOH, when reacts with H2SO4, it will form Na2SO4 and water. So this is sodium sulfate. It is also called normal salt. Now, tribasic acids. An acid which produces three hydrogen or hydronium ions by the ionization of molecule of the acid is called a tribasic or triprotic acid. For example, H3PO4, that is phosphoric acid, and H3PO3, that is phosphorus acid, are tribasic acids. They ionize in three steps. We can write the chemical reaction. H3PO4, when reacts with water, it will form H3O positive and H2PO4 negative. Now H2PO4 negative, H2PO4 negative, one negative is there. H2PO4 negative, when reacts with water, it will form H3O positive and HPO4 negative. third step is when HPO42 negative reacts with water, it will form H3O positive and PO43 negative. And tribasic acids form two acid salts and one normal salt. NaOH, when reacts with phosphoric acid, it will form Na2NaH2PO4 and water. This is sodium hydrogen sulfate, or we can also call it as acid salt. Sodium hydrogen sulfate or acid salt. Now, in the second step, when NaOH reacts with phosphoric acid, it will form Na2H PO4 and water. This is called disodium hydrogen phosphate. Or we can also call it as acid salt. In the third step, reacts with H3PO4, it will form Na3PO4 and water. This is sodium phosphate or normal salt. Thanks for watching Edupedia World videos.